petal curves, R equals A cosine of n theta, or R equals A sine of n theta. N is positive, you have even integer. And also remember the curve has 2 n petals. So if it's even, you want to double whatever n is, and you'll have an idea of how many petals you should have. Okay. If you know that it's an even number, you can double the petals, and there you are. You can plot points and see what you get out of the plotting of points. But some of the graphing, you want to do sketches like we did with our function sketches and our parent function sketches. We do rough sketches. So you got rough sketch and you got a T-chart for something more accurate. All right, this is R equals sine 4 theta. We could check out these two graphs because we want to know which one is correct because they both have 8 petals. So what we do is we're going to graph at 0, 0 and pi over 2 and see what happens. When we graph theta at 0, we see the radius goes out to 0. So here in the first picture represents that. Not in this picture because here it goes up to pi over 2. All right, so if n is a positive odd integer, it has n petals. So if n is 3, we have 3 petals. So folks, we can plot. We can kind of use a parent function. Well, we know cosine falls around the x-axis. So guess what? We got 1 petal on the x-axis. If you want to try the other axes, you could actually plot points to see that they do not fall there, and go ahead and try to sketch and graph. Next one we're going to do is R equals sine of 3 theta.
Bottom.
All right, so we got R equals sine of 3 theta. We know it's 3 petals. Here are options for 3 petals. We have this first one and we have the second one. We just need to figure out which one is the correct graph because we just did a model. We just did a sketch. So if I plug in pi over 2, I get sine of 3 pi over 2, which is equal to -1. And when theta is pi over 2, where it's -1, is definitely not right there. It's this one. So this is the correct graph. And this one right here is incorrect.